let's take a look at any that you had some questions about here, maybe. And I'll just, while you're getting stuff out and ready to go here, we'll just talk about the rules real quick. Any little tips I have. I've added a third website here under the web links. So I gave you that hard copy of the derivative rules, which is also online here under the documents section on our website. But so if we're looking at the derivative rules here, some of these simpler ones, with obvious ones we have, the product rule, the quotient rule, the chain rule, the derivative inside stuff. And then the ones with the star by them are the ones that you don't see quite as often. So one of the things I've been talking about was, what typically happens, you study and you do all this stuff, you get ready for the first gateway test, and then you don't pass it. And then you don't pass it. So on Wednesday, we'll go over the gateway test in class, and that'll be probably the only time we'll do that, or the last time we'll really talk about it. We'll be moving on then on Wednesday to other stuff. So then you've got to come in on your own time and before school, lunch, free block, after school, whatever, try to pass it. Then I'll get those graded as soon as possible, usually right away that same day or whatever. So by that next day, you should know. Now, typically, here's what I do. So in the grade book, what I'll do is I'll put 30. I'm trying to think how I did this last year. So there'll be a 30-point grade. If you make it on the first try, you get 30 out of 30, obviously. If you don't make it, usually what I do is I'll put in like a 7 or a 6 or a 5, and that tells you how many you got right. Okay? So obviously that's going to skew your grade because that's going to look like a 7 out of 30 to the grade program, right? And I think if I click so it doesn't include it in the grade, then I think it does that for everybody, including the ones who got 30 out of 30. So I don't think I'll do that. So just understand that if I put that in there like that, it's going to make your grade look worse than it really would be. Okay? And then that way when, yeah, go ahead.
Okay, so my local coordinator for my state here, if I don't pass and I would get like a 7 out of 30, she would call me. She would call school.
She would say you got 7 out of 30.
Yeah.
Okay.
But
I won't put you.
Can you like talk to me or something? If I don't pass it, then push it.
Right.
Awesome. Because she's gonna have a lot of paperwork to fill out.
And she's got to do all this stuff.
Yes.
She failed. She just failed something.
Yeah.
Because a lot of times people want to know. You want to know if you get. Tell you what I'll do for the first one. Well, here's what I'll do for the first one. Is I'll have those graded tomorrow. I will have those graded by the end of the day. I'm sure by the end of 4th block. So if you go online after school tomorrow and there's no grade in there, it means you didn't pass it. So there's either going to be a 30 or there's going to be nothing. Okay? And if there's no grade, it means you didn't pass it. And then, and again, unless you have a situation like that, unless somebody doesn't want me to, I don't have to put it in there. But that's what I have then. So let's say you take a second one and you get like 5. Okay, so I put a 5 in there so hey, it's been graded. But again, I typically get to those right away. But sometimes if you do it after school, then I got basketball practice, and I come in. Usually after basketball practice, I'll grade them right away and put them in. But if something comes up and I don't get a chance to, I might not get it until the next morning. So, if you want to know, come in and see me right away in the morning and find out how you did it. But again, what I was going to say then about that is, so typically what people do is they'll look over what they missed on the next one, and then they'll a lot of times want to take the next one right away. And what happens is there's not a 2 to the x, or there's not a log base 2, or there's not an arc sign on any one we've had so far, and all of a sudden on the third one of those shows up, like an arc sign or cotangent or something like that. And you haven't looked at those for a while. And all of a sudden now you're sunk, because now 2 of these functions or 3 show up that weren't on the other ones, and now you miss those, and now you're, whatever. So make sure you look this over repeatedly, so you just review, these ones that don't happen quite as often, okay? Like some of these down here, tangent, cotangent, whatever. All right, now under the web links again. I pulled this one up. This is one I've had in the past. This is from Jacksonville University. Again, you see it says Gateway Test, Math 140s their Calc 1, Math 41s their Calc 2. So they've got a bunch of different tests here. And now, unlike that Arizona State one where each test got a little harder, Test 1, Test 2, had some implicit differentiation, stuff like that. These are all pretty similar, and they're actually fairly easy, I think. But then at Jacksonville University, they're required to get 7 out of 8 right. So it's a little higher bar than 8 out of 10. But these look a little simpler to me than what ours is. But it's not bad practice. I mean, it's got some basic ones. There's kind of a chain rule, in a chain rule, another chain rule. Here's a quotient rule. Here's an E with some stuff on the inside. Here's a product rule. Here's a quotient rule, So what I noticed is they don't have any implicit differentiation on theirs. And so, again, make sure you go through and practice some of those. And we can do one today. We can do some of that. Whatever you guys want me to work through here, I can do today. Okay, so I've added that one as a third website you can go to. All right, so has anybody got one on page 195 or off of the website that they tried or did, wanted to ask about? What's that? 27 in the book? All right, okay. So y equals, what is it, a fraction? Natural log over the square root. 2 plus cosine x to the 1. Okay, so this is number 27 in the book. Okay, so quotient rule. So we start with the derivative at the top, which would be 1 over x, times the bottom left alone, which would be this, minus the top left alone, times the derivative of the bottom. Now, I can tell that's going to be messy, so I'm going to put some parentheses there. So the bottom left alone. So what do I do for the derivative of the bottom? Exponent first, right? The outer function. So I'm going to bring down the 1/2. I'm going to leave the 2 plus cosine alone to the negative 1/2 times, I need that. Let me get a different color here. A couple of people in their class said they were going to bring colored pencils to the test tomorrow so they could do this with theirs. But so the derivative of the inside would be just that red part, right? So what's the derivative of 2 plus cosine? Negative sine, right? Because the 2 would be 0 and then negative sine. Now, when I look at this, and then don't forget the bottom, all squared. Now, what's 2 plus cosine to the 1/2 squared? It's 2 plus cosine, right? Square root squared, just be 2 plus cosine. Now, you can argue it should have absolute value around it, maybe, and that would probably be true, but I'm not going to make you do that. My guess is the calculator might do that, actually. So now you step back and you think, what could I maybe simplify here? Well, nothing that I would make you simplify, really. I mean, this negative, other than maybe this negative, because if you look at this, I got 1, 2, 3, 4 things multiplied right here, right? And positive, 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 and then this is negative. So to me, this negative can come out here and make a plus with that. I'd like to see you do that. But other than that, I don't know that there's a whole lot you can do here. Now, could you factor out this? You treat this, here's a group here, we've always said you got u prime v minus uv prime all over v squared. And we always think of the quotient rule as one thing minus another thing. So it's this thing, and it turns into plus this thing. We could factor out a 2 plus cosine to the negative 1/2, but we're not going to get into these negative powers, messing with factoring those out. That's something we're going to do more of later. But
so is that maybe how they got the book answer?
Probably.
Because
what do they have on the bottom?
they have 2x times 2 plus cosine x that quantity
to the 3/2. So what they do is they take out a 2 plus cosine to the negative 1/2 on each of these, which you can do. And that would turn this into just a 2 plus cosine, and then, right? Because when you take out a power, remember, what do? If you have x to the 5th and you take out x squared, what do you have left? X to the 5th, take out an x squared. You subtract the powers, right? So if we take out a power of negative 1/2, well, you had a 1/2 and you take out a negative 1/2, what does that end up being? Power 1. So you would have a 2 plus cosine here and you wouldn't have anything here because it would just be there. Well, so out here you'd have a 2 plus cosine to negative 1/2, which could flip to the bottom as a 2 plus cosine to the 1/2, and a 2 plus cosine to the first, add up a 1 and a 1/2, and you get 3/2. And that's what they did.
So that's just what was thrown, just the book answer.
Yeah, that's what they did. So, but I would not make you do that. So you just go to there and find. Okay? What else? So really not much to simplify there. There is another one I want to do that does have some simplifying on what I'm talking about. But again, less than half the problems would take much simplifying or anti-simplifying. What else? 39. That might be the one I was thinking of. That's the one with the x e to the x. Yep, that's the one I was thinking of. Good. Log base 2, and there's a cube root. So x e to the x all to the 1/3 power like that. Okay? Now I would say both of these that we've done get into the more difficult range. You know, when you're looking at 10 problems, some easy, some medium, some hard. I'd say that Jacksonville University one, those are easy to medium, probably. So those are good to review, because if you're going to get 8, you got to get all the easy ones and all the medium ones, right? You know what I mean? And maybe a couple of hard ones you don't get, whatever. But, so those are good to practice, you know, even though they might not be as difficult as a few that might be on the Gateway test. If you can be solid on those, that'll really help you. All right, where do we start here? It's log, right? The rule for log is always 1 over the inside. That'd be x e to the x to the 1/3 times 1 over ln2, that's the rule, times the inside derivative, right? So now we're ready to tackle that. So how do we do that? Bring the power down. 1/3, leave its inside alone, to that negative 2/3 times derivative of that inside, which would be the blue part right there. And how you can do that? That needs a product rule. So then that's where, again, I better put a set of parentheses, because now that's really important, because the product rule is going to have a plus in it, so I'm going to need parentheses there. So now the blue derivative of x is 1 times e to the x left alone, plus x left alone, derivative of e to the x is e to the x. Right? So then we step back and we ask, is there anything that, and somebody asked me in the other class, they said, what algebra do you need to know? That's hard to describe, but I would say it this way. Combining things you need to be able to do. If x squared and x cubed, you can multiply and get x to the 5th, or 3 times 2 is 6, or the minus and negative turns to a plus, right? Combining things, those kind of things, I think you should be able to do. And then the factoring and canceling, right? So maybe that can happen. Those, I mean, really, in a sense, those are the two main things. Those are the two main things. So to me, I'd say, well, can I combine some things? Well, when I look at this, I see, now, these black parentheses here, in the end, to me, probably didn't need to be there, right? Because I got one thing times another thing times really another thing times another thing. So the blue thing I got to treat as one thing. This and the 1/3 is actually a separate thing, I guess, too. Really, that's what I got. So I can rearrange now. And to me, can I put this together with this? Because isn't this a x e to the x to the negative 1/3? then I can add that power with that one. Negative 1/3, negative 2/3 would be negative 1. So I could have 1 over ln2, and then the 1 over 3, I can just put that 3 in front of that ln2. I could have x e to the x to the negative 1, and then I could have e to the x plus x e to the x. Now, is there any more? I think there is something more I can do here. Yeah, I could factor out an e to the x in those parentheses. Now, why would that be good? Because this negative 1 power, what can I do with that? That can go to the bottom. So actually what I have is I have e to the x, x e to the x on top, and that can go to the bottom. So I've got the 3, I've got the ln2, and I've got x e to the x to the first down there. Do you see why now factoring out an e to the x would be good? So on top, if I take out an e to the x and have 1 plus x, and then here I have 3 ln2 x e to the x, now that e to the x and that e to the x can cancel. So combining some things like with powers, like this x e to the x thing here, and again, and I could do that because those were all multiplied. All those groups of things were multiplied together. The only plus sign in there was over there, so as long as I kept that blue thing together, I was good. But again, I can't imagine there'll be 2 of them on there that would have that much kind of simplifying. I'm more interested in, can you follow the derivative rule? Okay. To me, it's more important. I'll be honest. To me, it's more important that you can do this problem right here. Right? Here's what I don't want to see. Here's what I don't want to see tomorrow. I don't want to see people doing this. This is going to drive me nuts. Right? That's what I don't want to see. Right? What's missing? Those parentheses, right? I don't want to see. I mean, that's going to be wrong. It's going to be wrong. Okay. So when we talk about simplifying and algebra, parentheses, stuff like that, there you go. That's the answer. Right there. Okay. That kind of stuff. So be careful. Be careful. Or, geez, where's another one where that comes up? X squared plus 3x to the 8th, that kind of problem. So you bring down your 8, you go x squared plus 3x to the 7th times 2x plus 3. You see that all the time. Right? It's not correct. It's not correct. All right, what else? What else?
I had number 53.
53. What is that? Sine squared x cosine x, like that. And again, the biggest problem people have on that is they forget that that's really, I got too many parentheses. Right? It's really that, right? It's sine of x cosine x all squared. So the outer function here is what? The power. A lot of times people look at this and they think sine's the outer function. No, it's the square that's the outer function. So where do I start? I start with the power. So what do? Bring the 2 down. Sine x cosine x to the first times. Now let's be careful here. Here is my inside in red, right? So I got to do the derivative of all of that. Right? So here's where planning ahead with the parentheses is important, because I can also tell I'm going to have another inside. I'm going to have that here in a minute. And that's going to be a product rule. but I'm not ready for that yet. I'm just doing the red part. So I need a big set of parentheses. All the rest of it's got to be inside those red parentheses. Okay? So now I'm ready to do the red. Well, what's the derivative of the red? Cosine of x cosine x times the derivative of its inside. But those blue parentheses have to stay inside those red parentheses. Right? So now I'm ready to do that. Well, what's the derivative of x cosine x? Well, the derivative of the first would be 1, cosine left alone, plus x left alone. What's the derivative of cosine? So that's going to turn to a minus. So it's going to be x sine x. Okay? But now there's really nothing I can put together. I got a 2 times a sine times a cosine times this. I mean, I can distribute those, but that doesn't do you any good. I mean, that doesn't. I talked about that. I wouldn't distribute things unless it helps you to keep so you combine something. That's pretty much it. That kind of reminds me of one I was helping someone with this earlier. It was earlier this period. It looked like this. It was, let's just make one up here. X squared, and then it was sine of, let's just do x squared plus 3x, something like that. Okay? So this is a little different in the sense that this one had a product rule way on the inside. Here the product rule's the outside, right? The product rule's the outside on this one. So now, like on this one, we had our parentheses was here times all the rest of this, but now on this one it's a little different. So we start with what? Product rule. So the derivative of the first would be 2x. We leave the sine of x squared plus 3x alone, plus x squared. And now, when we do this one, we're going to have a derivative of the inside, right? But that's only going to get tacked on to this stuff. It's not going to be a part of this over here, right? So, cosine of x squared plus 3x times 2x plus 3. And now that 2x plus 3 again has to be in parentheses, but that 2x plus 3 is only attached to this part. And the person I was helping, they were times about the derivative inside, and they felt like it needed to be times all of this. So they were putting all this in parentheses and timesing that. And that's not true. That's not right. So, I mean, it's not like you can just start throwing parentheses in there and be correct, right? You can actually screw things up by putting them where they're not supposed to be. So the 2x plus 3 is only tacked on here at the end when we did this last part, when we did the derivative of the v part. Okay? So then you look at that and you say, what could you do? The only thing, and I said you don't have to distribute. You say, well, you could put the x squared in there. Well, yeah, you could distribute. You can make x squared times 2x be 2x cubed, but I wouldn't make you do that. You don't have to do that. If there was an x squared here and just a 2x setting here, then yeah, x squared times 2x you should multiply together. But not there, so I just leave it. Yeah.
If the sine was squared as well, the whole thing.
Oh, gosh, yeah. Wow. That'd be ugly. If this was sine squared?
Yeah.
Yeah, so then, yeah.
Parentheses, or the derivative of that would be, you have to do inside of the inside.
Right. So I would need more room. But if this was sine squared, right, which really means all this squared, right? So now you'd have derivative of this, you'd leave this alone, so this would all be squared, right? Plus the x squared left alone, times now, right? Now I would have put a big set of parentheses just here, just knowing that, hey, this is going to be a mess. This part, doing the derivative of that part is going to be a mess. So yeah, you'd bring the 2 down, you'd leave the sign alone, x squared plus 3x, times the derivative of that inside, so that'd be cosine x squared plus 3x times that inside 2x plus 3, right? I mean, it just, you just keep tacking on that inside and that inside. But even then, you'd just be done there. There's nothing more to do with that. Yeah, that would be a hard one. You would not get a page like 10 of those. No way. Okay? I mean, there'll probably be one on there that's like this. Or something like that, right? I mean, there's going to be some kind of straight power rules, or maybe a sine and a tangent, or I mean, there's going to be some of that too. So they're not all going to look like these crazy ones we've been doing. That's why I think sometimes I kind of added this page on here. I think sometimes it's good to this is these kind of these basic these are easier to medium kind of ones are really what we want to make sure we can do. Yeah, we get some of these harder, uglier, messier ones. We'd like to be able to do those too. But a lot of them are going to look more like this also. Okay? Any others? And you have some time here to ask individually. That's kind of my plan today, is to just practice here, let you work together a little bit. You can go on any of those 3 websites. You can do practice, page 195. What about implicit? Should we do one of those? Just to kind of review what that's all about. And the thing about implicit is you can just make them up. Now, it's hard to know what the answer is. You pretty much got to ask somebody or ask me or whatever to check it for you. But combination of x's and y's. I'll just a little hint here. I like to throw in a xy where they're multiplied, because that's a product rule kind of thing. So you might have something that's an x squared y minus sine y or something like that equals x cubed. I don't know, let's just make one up here. Just a mixture of x's and y's. I'm not going to make it a whole bunch of like inside stuff and things like that, probably. I told you on that one Arizona State worksheet, they got into a couple at the end that had x's and y's inside other things. Probably not going to be much of that. Okay, so where do we go from here? So what's 3y squared? 6y, y prime, right? Whenever you do the derivative of a y, the output variable, you do the normal derivative, tack on a y prime. Plus, and be careful if there's a minus here. If there's a minus here, you should attach it to that x squared, okay, when you do your derivatives. So anyway, derivative of x squared, 2x, leave the y alone. Plus, no, we don't do y prime because we didn't do the derivative of the y. Only when you do the derivative of the y, you tack on a y prime. So x squared, just 2x, leave the y alone. Plus, x squared, derivative of y, y prime. Minus, derivative of sine y, cosine y, y prime. Whenever you do the derivative of y, you tack on a y prime. Do the normal derivative. So sine y, the derivative of cosine y, tack on a y prime. Equals 3x squared. So I got 1, 2, 3 that have y prime. So those should stay on this side. So 6y y prime plus x squared y prime minus cosine y prime should stay on this side. The other side, I got 3x squared, and I'll subtract the 2xy. So keep the y primes together. So again, it's just take it one step at a time. Do the derivative part, but be on the lookout for these ones that are grouped together where you have to do a product rule. Because that's a part sometimes people miss. And if there's a negative in front of that, and you do the product rule, make sure you attach that negative with the first thing. So we take out a y prime, and what do we got? 6y plus x squared minus cosine y equals this. And then we divide That's pretty much how those look all the time. Right? You do the derivative. Whenever there's any y's, you tack on y prime. You get all the y prime terms on one side, get the other terms to the other side. Factor out the y prime and then divide. Missed a parenthesis. Okay? Alright, so rest of the time, work on page 195, work together, help each other out if you want, that's fine. Go to the websites, work on those, get ready to go for tomorrow. And I'll just sit up here and the answer book's up here, come up and ask questions if you got it. Okay?
I was.
Oh, that's right. Yeah. I did take a look at that. Thank you.
Trevor, did you have that homework from the other day when you were gone on Friday? 3.4.